Sometimes it's useful to represent a complex number on a plane, or you're all familiar with the Cartesian plane for x and y. The Argand plane is very similar. So if we had z, the complex number, is equal to x plus I, y, then instead of having the x-axis and the y-axis like we have in the Cartesian plane, in the Argand plane, this is called the real axis, and this is the imaginary. So as you know, x is the real part of the complex number and y is the imaginary part. So it's simply a matter of coming out here x units and up the y-axis, or the imaginary axis, I beg your pardon, to go up there y units, and this is the representation of the complex number on the Argand plane. You've come out x units up here and gone up y. So if we had z equals negative 3 plus 4i, we draw our Argand plane, the real, the imaginary, and we've got to come minus 3 on the real and go up to 4 on the imaginary. So the representation of z would be to there. So we've come out minus 3 real, and the imaginary is up 4. Moving on from that, we need to come up with a definition of what mod z is. Mod z is sometimes just the length, the magnitude of z, or also called the absolute value. So a shorthand way of writing, we can either write mod z like that, or we can write that as an abbreviation for mod z. And mod z is simply the modulus of x plus iy, and by definition it's the square root of x squared plus y squared. So mod z is simply the square root of the real squared plus the imaginary squared. As an example, if z is equal to minus 3 plus 4i, mod z is equal to the square root of minus 3 squared plus 4 squared, which is equal to the square root of 9 plus 16, square root of 25, which is equal to 5. So that is our definition of mod z, and we're going to use mod z in much more detail as we progress on through this course.